Hello, everyone. Yeah, my name is Haidar, and I am Professor of Biotechnology and, of course, President of Institute of Science and Modern Technology in the Rojava University. Of course, we are a young university, but with big missions and goals, especially in the ecosystems, ecology, and women and men equality. Ladies and gentlemen, distinguished guests, it's an honor to speak today about a subject that can change lives, reshape communities, and bring dignity to communities long left behind. I am talking about the importance of scalable and technology with a special focus on nanomembrane innovation for the future of uh, undeveloped countries. You know, a lot of us using in undeveloped or developing countries with a specific kind of crisis. We see different kind of wars, civilians wars, and of course, wars between different governments, especially in the Middle East, in the Africa, and of course, in the other part of the world, such as European countries, and of course, in the maybe other part of the Asia. Anyway, uh, we have different kind of isolated communities. So in such situation, in such a super big crisis in the world, that we have a big challenge still, maybe more than 700 million people still live without access to safe drinking water, millions or more lack reliable sanitation or affordable health care and clean energy. In such a situation, the heartbreaking truth is that in many undeveloped regions, the problem is not a lack of idea or even lack of technology. It is the lack of technology that can scale. A brilliant laboratory solution means little if it can't be produced affordability and deployed widely and maintained locally. But why scalable technologies matter? Scalable technology is not about the most sophisticated invention. I am talking about designing solutions that can start small, prove their value, and then grow exponentially without losing quality or affordability. Scalability means low cost per unit as production grows. Adaptability to local conditions, it's very, very important for our situation. And of course, whenever I'm talking about such technology, I mean minimal dependency on highly specialized resources. In short, scalability is the bridge between invention and important. In such situation, I think membrane technology can be a game changer. This is where nanomembrane technology shines. These membranes are produced using different kind of engineering or laboratory techniques at the nanometer scales. They have ability to selectivity filters and purify substances with precision and separate viruses, bacteria, heavy metals, and organic pollutants from water or any other kind of resources. In undeveloped countries, nanomember systems can, of course, transform or change contaminated water resources to safe drinking water without we need to power hungry or big plants. I am talking about operating this membrane, this minimal energy input. Even we can using this technology via solar or manual pumping systems. Of course, by integrating into portable devices for households or local clinical or small communities, the membrane technology can shape our communities. The matter is beyond the water. You imagine a lot of our rural clinics with straight water on demand, schools where children can drink safely from their own walls, or community where women and children no longer have to walk miles for water. They can focus on their educations or their works. In such a situation, of course, I don't talking about dreams, I'm talking about the real situation. So that we have to commit to investments or training and focus on local manufacturing so that maybe we can solve some of our communities and societies problem. It's time we have to encourage partnership between societies, between entrepreneurs, and between local communities so that we develop such a valuable technology. We have to focus just not on inventions and very advanced laboratory protocols. We have to develop and deployment this technology. We have to focus on ensure local ownership and maintenance capability. In this case, I bring here some stories or some research that we have done in our universities, in our institute. Actually, I don't want to focus on details or protocols of these techniques. I just a little want to take your attention on the applications of these membranes. For example, the first studies were carbon quantum nanomembranes. I don't want to talk about details because after me, I think in the next sessions, our graduated master's students want to give more detail about these procedures and these studies. You see the different membrane that we fabricated for quantum, using quantum, carbon quantum, that's for separating some hydrogen disulfides and other pollutants from natural gas. Actually, I told you we are living in such crisis or the situation that a lot of times we lost our infrastructure. Sometimes we lost our refineries because of war, because of attacking, we are attacking by other sides. So we have to search for another alternative. In the case that we don't have our refineries, we can't purify our gas in the industrial scales. We approved that this nanomembrane can be great. At least we can purify our home using gas cylinders that you can see in this picture. And of course, our results show that the membrane can effectively and successfully separate or purify H2S from the natural gas. Another case study was using this kind of cellulose acetate membranes for purifying produced waters. Of course, we have many volume and big volumes of produced water. It doesn't just we lost this valuable resource as a drinking water, and of course, it affected a lot of our agricultural fields. So this technology and membranes proved that we can use this membranes at the low scales to purifying some kind of this produced water. Of course, we use it for purification of gasoline by pervaporation membranes. You see the different kind of membranes. I don't want to talk about more details, but again, it's amazing story. Whenever we can using this kind of membranes for purifying gasoline, because I told you a lot of times there isn't refinery, so local people can using this kind of membranes and use this kind of membranes to purify the raw gasolines and sold these gasolines to local people for local, at least for local use. I think it's amazing whenever I see such application. Of course, preparation of antibacterial polymeric membrane. It was another example of successful membrane that we studied and we used it in the local scales. Our membranes showed good laboratory and, of course, local applications in the case of removing bovine serum albumins, and of course we use it for treating Tiger River. Our data showed that one of these membranes, M4, had a great effects for removing bacteria, turbidity, BOD, and COD. Of course, in this figure, you can see how these filters or these membranes could purify the water from different kind of bacteria. The more amazing about this membranes, we had a case, we had a studies, and we had a report that in one of our hospitals there are nosocomial infections, and hospital infections affected different parts of the hospitals, and they were going to knock down the hospitals. After our investigation, we understand the main source of these pollutants and infections is from their piping system and water source. Using this fabricated nanomembranes, we could solve this problem at the satisfied levels, and a lot of our friends were very happy to solve such a big problem. And of course, the last story that I want to talk about using hemodialysis membranes. Of course, one of the membranes that we have used and we are checking still is a cellulose acetate polyvinyl alcohol blend. Of course, these membranes is studied and I think is applied by other researchers around the world. But here, of course, in the region, we have a big problems in the case of chronic kidney disease, and it's become a crucial threat to our patients due to high mobility, high morbidity, and lack of cost-efficient treatment. A lot of time, our patients have to pay a lot for hemodialysis membrane that we have to buy from outside, and a lot of time there is an opportunity we buy the hemodialysis membranes from outside because of the sanctions on the Syria, because of the crisis of the war. So in these studies we used it hemocompatibility membranes for dialysis, and our experience in 3 volunteer patients indicated that these membranes can clearance or clarify about 92% for urea and about 80% for creatinine. And I think it was a good and optimistic. I am optimistic about the application of these membranes for hemodialysis in our page for our patients. What about future? I told you maybe it's about 2 or 3 years. A little bit I focused on membranes, especially with other. We have a great colleagues such as Dr. Haba and Dr. Sama. I want to appreciate their cooperation with our institute. But in the future, it's on my mind. I like to merge biotechnology with nanotechnology. And of course, I want to expand special resistance recombinant enzymes so that maybe we can have a hybrid nanozymes for improve our fabricated membranes. I'm searching for and I'm focusing on hybrid systems so that coupled with catalysis or plasma treatments, and of course. Another amazing, interesting topic is aquaporin mimics, because we have a very successful aquaporin mimics in the medicines, and of course in the genetics. Just now we have aquaporins or nanopore for sequencing. I think This science and this technology can be more helpful in the case of membranes. And of course, another matter can be interesting for me is using smart membranes such as self-cleaning and sensing membranes. I don't want to take your times, dear colleagues and ladies and gentlemen. At the conclusion, I just want to conclude that nanomembrane technology, when scaled wisely, it's not just a tool, it's a catalyst for health, education, and economic growth, especially for our communities. And let us not be satisfied just at this level. We won't be satisfied just at the laboratory scale. We have to scale up our achievement, our results, so that the world's most vulnerable communities are not left behind. But instead, I hope the first to benefit from the technology of tomorrow will be these communities. Thank you very much.
Thank you.
If you have any question, I'm at your disposal.